Ready?
I'm ready. You ready? Play on.
3, 2, 1.
It's been a long day out in the tractor, and I reckon I've earned myself a bit of a chinwag about
hacking.
So I've tweeted about my hair, I've tweeted about my shoes. I think it's time I tweet about...
Hacking?
Well, everyone's agreed to drop everything because it's 10:40, and Kirk and Andy have declared today's topic is...
Hacking?
Kirk and Andy's Hacking Hour.
Hello and welcome to Kirk and Andy's Hacking Hour this early Wednesday morning.
Early Wednesday morning. Good morning, good morning, good
Thank
morning.
you for coming along. So, who are we? And why are we here?
So good morning. So my name is Andy Prowl. I am the Managing Director and Founder of Aura Information Security. We do penetration testing and security-related stuff. And with regards to the image there, if you're coming along to the security Spidey sensors this afternoon, you'll understand why I'm Spider-Man. Also, I remember one of these classic words of wisdom from my children. Always in life, be yourself. Unless if you can be Spider-Man, in which case, always be Spider-Man. So that's me.
Okay, and I'm the geek on the right-hand side, so I work at Xero. And I'm also much faster at introducing myself.
Yeah. So we've got a bit of a session this morning on hacking and cybersecurity. So I guess we've got a couple of items from the news and a bit of a picture of the world first before we get into our hacking demos. So the first thing is, are we winning the cybersecurity war? What do you reckon, Kirk? Are we winning, mate?
Yeah, sure.
Oh, good. So one of the I'd actually challenge that. There was recently an attack over in the US. It was quite a high-value attack. The attack itself was fairly complex, and the payload, I'll show you the payload in a minute, was actually a 71-character payload that caused a massive financial damage over in the US in, I believe it was February of this year, 71-character payload. So from this advanced attack, with 71 characters, what sort of damage do you reckon it could have caused? 71-character payload.
I don't know, probably, remediation, maybe $100,000?
$100,000. No. So it costs more than $100,000, this 71-character advanced payload.
$100,000 per character?
$100,000 per character. No, more than that. So more. How much could this be? $1
million per character?
Million per character. More.
2 million?
2 million per character. Keep going. You're way off there. Keep going.
2 million and 5?
It's not a bloody auction, bro. Last minute bidding. No. Keep going. Get creative.
10 million.
10 million per character. Way off. Tiny. More than that.
What's higher than 10? 100.
100 million New Zealand, Australia, or US?
Which one's worth more? US.
Yeah, almost. Okay, the 100 million US per character. Not even close. Go up. More than that.
Well, can't you ask some other people?
Okay. Anyone else got a bigger number than $100 million per character? There's a prize. $1 billion. A billion. He's after a big prize. $1 billion per character. It just wiped out all the money. Poof.
A Google.
No.
A Googleplex.
A Googleplex. So it was actually, so this attack was worth $1.91 billion per characters. So that's how much this attack cost, right? So this advanced 71-character payload. Anyone know what it is? Oh yes. It was this tweet. So this was the classic tweet. So just to put into context the security world that we live in at the moment, this was the tweet that got through because the Associated Press is... Was that you or me?
You do it?
Oh,
It's definitely you.
It's me. I'll stand still. The Associated Press's Twitter account got hacked. The Associated Press Twitter account. Was that one? Oh! Got hacked. And so anyway, I just stopped moving. I can't do it. And so for 71 characters, it wiped off $136 billion off the Dow Jones. So what are we talking about here? So I guess the world of IT security where it's like you're worried about your main systems, but your Twitter account getting hacked, so this caused $136 billion. Sure, the Dow quickly responded, but I was absolutely gobsmacked by this high-value attack of 1.9 billion per character. So, all right, so that's what happened in the US. What else is the threat landscape looking like? So I guess lots of people would have heard about these two fellas, LinkedIn and Yahoo Voices.
Yeah, so LinkedIn was last June in 2012.
Absolutely.
So they got hacked through a high-tech, sophisticated mechanism.
This was a pretty much advanced persistent threat. This was hardcore zero-day stuff.
Yep. So they got attacked with SQL injection.
Absolutely.
Yep. And their entire password database, well, not the entire password database, but 6.5 million of the passwords got stolen.
Exactly.
And luckily they were stored securely.
Yes, they were. So they were SHA-1 hashed.
Yeah.
But that was it. Now, anyone know of a step that was missing if I SHA-1 hash it? There you go.
Yep, not enough sold.
A billion prizes to that salty person over there. Yeah, so they were just unsalted SHA-1 hashes, which is a bit of a fail, but that's fine. As opposed to Yahoo Voices, they had quite a different attack, didn't they?
Yeah, so Yahoo's this small company, and Voices is an even smaller product that no one uses.
Correct.
And 453,000 of their passwords got
still
stolen.
quite a few, nearly 500,000 passwords. What was the difference with that attack, though? Because it was quite a different...
Yeah, it was quite a sophisticated attack, very advanced, as you were saying. It used SQL injection.
It's SQL injection, that's right. Jeez.
They didn't need to salt their passwords because they also didn't hash their passwords.
That's correct. Correct. So they had unsalted, unhashed plain text.
Yeah.
Ooh,
so the big boys don't get it right.
Okay. So that's cool. So, but here in New Zealand, do we get it right? Mostly. So what's been happening here in NZ? So there's a bunch of stuff in the news. So in fact, it was quite hard to filter down for a couple of minutes of news from New Zealand. It was actually quite tricky to filter out what's some of the best news stories. But I guess we couldn't kind of start off without our best friends, our great hosters of, well, publicly sharing information.
GCSB?
Yeah, exactly.
Oh, I wouldn't call them friends. So,
So we've all heard about all the mega stories, and I guess probably the most interesting thing is that when there becomes an issue with whether or not legal access to information is valid, at least here in New Zealand, we can easily change the laws to make sure it works. So we have no problems with privacy.
Flexible, very
we
flexible.
have highly flexible laws.
Yes.
It's not an issue at all. We don't know. So, okay.
So what was the next one? Ministry of Social Development. So you would have heard about this. Apparently they had some kiosks in their branches where you could go in and apply for jobs. Forgot to plug them into a different network than the rest of their network.
Yeah.
So 3,500 invoices, including personal records of children, payments to psychologists, and all sorts of other embarrassing stuff was snaffable off the network just by connecting to a file share. And this triggered a huge security review by Deloitte, which probably cost hundreds of thousands of dollars. And then the government, per day, Aura would have been much cheaper. They would have been $50,000 a day. And then, of course, it led to the government CIO instituting a government-wide analysis and audit of all the systems in government, of which I think they looked at 215 on paper.
Yes.
And decided that some of them were okay.
A paper-based review. So at least those who on paper said they were bad were recorded. So that was all good. I'm sure an honesty-based, paper-based review is a pretty solid audit. Yes, that's what we do. Are you secure? Yes or no.
Oh,
Don't
and by the
know.
way, if you tick no,
fine.
you'll end up in the newspaper.
Yeah, exactly.
If you tick yes.
If you click yes, it's like, I don't know. Well, that's fine. At least you're not a no.
It's the best survey monkey ever. Are you secure?
Is that what they do? So what else we had? So telecom, so they wouldn't have had a breach, would they, of anything?
Well, so Telecom outsourced their email for all their customers to Yahoo, who outsourced it to MSN, who outsourced it to Yahoo Mail, who outsourced it to something, or whatever it was, and 22,000 of those accounts were hacked, and people were sending out spam from extra accounts.
Yeah.
But Telecom said, it's not so bad, it's only 5% of our customers.
Exactly, which is fine. Which, and I guess that's it, is that if you always have a bigger amount of things that are still not broken yet, then that's plausible on the things that are broken. So I guess that's fine. Yeah.
So this was a funny one.
Herp derp FBOSS. Can
Yeah,
you read
this
that?
is not really a hack. This is more just something funny. So, so people noticed that when they went to pay for stuff at the store, that the FBOSS machine said herp derp on the front of it. Herp derp. Oops, something's wrong. And that was just, I think, a case of a developer just pushing a message instead of to the test environment, pushing it to the production environment.
Yeah. Whoops.
Which,
Yeah.
I mean, that's fine if they're plugged together. Then it's probably easy to do that.
Exactly. So, yeah, but, you know, because I must admit, it's very rare that a developer would actually work in a live environment instead of a test environment. This must have been the one time it happened.
Yeah, and
it's
lucky that's not in any important kind of company that deals with credit cards and payments or anything.
Piffle, absolutely fine. I guess what's more scary is the fact that this happened, or that in fact about 3.3 million transactions went through whilst this was still on the screen. So it just shows user behavior. Beep, beep, herp, derp, yeah. Users, eh? Users.
Earthquake Commission, so this is a little company gone big, or a little department gone big. They accidentally sent a spreadsheet with some hidden columns in it that contain the details of 83,000 people, their properties, and their claims. Awkward. Email.
Oops. All fine.
But it's not all just us in New Zealand. You know, Australians get things bad as well.
Yes, they do. And so we were actually over at, funnily enough, over at TechEd Aussie last week. And in fact, the amount of cock-ups that they made in Australia were much, much bigger. There were hundreds. So in fact, they are far worse than us. But the one that we actually kind of liked the most, obviously we don't like any hacks because, you know, we are security professionals and they're all bad. But the one that was actually quite funny.
Yeah, this was quite funny. And also it was at a casino as well, which is good because this is a casino.
Ooh, spooky. Spooky. So Crown, so this was Aussie casino chain. It was a bit of like an Ocean's 11. So the hackers actually made off with 32 million bucks. And basically were hacking. They had a large gambler as part of the gig. They had some internal employees and they hacked the surveillance systems.
Was it Kim.com?
It might have been.
Oh.
Is that how he's funding his run for Prime Minister?
Large gambler.
Off large gambling.
Yeah.
Okay. So I guess, so basically the hack that was involved was indeed a hack of the surveillance system that then was used as the gambling heist.
Yes, I think
Cool.
I think he knew what was on other people's hands because the cameras behind were zoomed in on there.
That's right. That's where it's really useful to have 400 million cameras, as long as you're the only person watching what people are doing.
But the cool thing was that it was a casino, so they didn't even bother reporting this to the police.
Ooh, God no.
It's like $32 million.
Whatever.
Yeah.
Okay, so there was also this other little crowd who went up as who are now absolutely legitimate competitors to TradeMe.
Yeah. So TradeMe is a little company in New Zealand that's kind of taken over online buying and selling, and competitors crop up all the time. And a noteworthy one in October, I think it was last year, was launched to much fanfare. They had advertisements on buses, and their CEO was talking about how many servers they had. It was like 20-something servers, and how they'd invested
40 servers.
40 servers.
Dude.
Cool.
Yeah, mate.
And how they'd invested all this money in development.
And the ads were pretty cool.
Were they?
Oh, no.
No.
So
hang on.
who signed up to Wheedle on day one? Because there was a couple of people who got in before it was taken down.
Yeah. Yeah, so Wheedle was going for about day.
Yes.
And then some people actually used it.
Yes.
And then by day 2 it was offline again.
Absolutely gone burger. Which I kind of, that's a fairly drastic response, as we're actually going to take the whole thing offline. It's
Yeah, I mean, it would take a few days, I guess, to fix if you had small security issues. How long did it take them to come back online?
So they came back online in April. So
6 months.
Yeah, there was a couple of wee bugs. And I guess so some of the biggest ones that made the press were the plain text username and password going in the cookies that were being stored on the client. Well, I guess Yahoo Voices got away with it, sort of.
It's a massively distributed database of passwords.
You know what?
Each password stored on a different client.
Do you think that
Redundancy.
could work? It is. It's massive redundant. Ooh.
Yeah.
There's actually some performance gains to be had there. Okay. So maybe this is the security talk where you learned that was a good thing to do. Wow. So what do they also had? They also had direct object reference and unauthorized updates. So the key result is that as a user, you could actually manipulate things like the buy now and the bid price on someone else's auctions. Which, if that's the sole thing your site is there to do, that's a fairly fundamental flaw.
It does make buying things a lot cheaper, though.
It does. So actually, if you're trying to look at a way of distributed authentication, nice, and a way that you don't have to worry about all of these auction engine rules, there you go. You see, it's actually quite genius. So, so look, one of the other ones that's actually we've seen more of this year. So I just thought I'd pop this up as a particular slide. So you have a look at this one. So hopefully you guys can see at the back, we highlighted in yellow and orange all of the reference to porn, porno, and porn videos. So this site here, so you might wonder if you were looking at this, you'd think, right, what sort of website would have this up? And we refer to it as search defacement because it was actually a Southern Hemisphere Ministry of Strategic Planning and National Development. Of course, being found high in the Google rankings for the Viagra links. So, and apparently this, so when you look at the strategic planning and national development, it wasn't actually around how they can increase population through free Viagra. That was actually not their policy. So what this was, so search...
What does Viagra increase then? Blood pressure?
Yes.
Okay.
So where these searches are coming from is that if you actually went, so you looked at the site that was coming up in the Google searches, you go and have a look at the actual site itself, view source behind it, absolutely no references anywhere to Viagra or to porn movies. However, if you were to browse the site as the Google bot, then all of a sudden the code would be returned or the HTML would be returned with all these links in. So the attack is that basically the hackers have got hold of the back-end content, whether they've hacked the CMS, hacked the web server itself, they're able to update the content. And instead of uploading malware, instead of uploading porn images, they upload these specific search tags that only appear if you are the Google bot or maybe the Bing bot. I think there's a crawl a day that happens from the Bing bot. And what it does is it means that you get search engine de-optimization.
It's the wrong audience to make Bing jokes.
Bing. So the point there is that if you've got a site that all of a sudden, and this is what we found, a number of clients where they suddenly disappear completely off the search list. So they're spending all this money on search engine optimization. But what happens is that they suddenly become blacklisted because now they're serving up blacklisted content on their normal everyday sites. So it's actually, it's more of a competitive hack.
Oh, yeah. And the most epic one, which we actually did talk about at our talk last year, so
I know,
our
but we've got to do
apologies.
it again.
I mean, the thing is, I guess it was technically less than a year ago, so...
Well, it was.
It did happen.
By about tomorrow. It'll be a year ago. But,
Yeah.
And so, for all of those people who attended TechEd last year, I guess we still have to kind of refer to this one. So who actually came last year? Anyone recognise the emails that came out for the fast registration? And so, of course, so for those who don't know, for the registrants, so this here was the email. You can see at the bottom, click here to print your barcode. So this is actually quite a good feature, so that you can preprint the barcode, skip all the queues. And if one followed the link, so this is actually Kirk's one. And so Kirk followed this link up here. So you can see, I'll actually, so there we go, secure.avenues.co.nz. And so Avenues have done a great event this year, by the way, so always full respect to Avenues. They, in fact, didn't write to this code. So what happened is that link, ID equals 673, that was fine. Now, Kirk was a bit worried when he saw QUFIU2DDI. Why was that a worry to you on the URL string, mate?
That's the same password I use everywhere.
Should I have kind of like redacted that for this demo?
No, I don't use it everywhere anymore.
Okay, good man. Excellent. You've now changed your 1Password. It was quite a good 1Password, though.
It's a great program, actually,
on.
1Password.
Yeah.
You install 1Password and you store 1Password in there and then you use it everywhere.
Ooh. Yeah, but you're not supposed to use the 1Password that you use for your 1Password as your 1Password on the internet. You do realise that, don't you?
Well, that's bad advertising, isn't it?
No, it generates other passwords for you to...
Well, then wouldn't they call it lots of passwords?
No. 1Password gets you into lots of passwords.
Okay, anyway.
So what this
Not
does...
an advertisement.
Yeah. So So if we have a look here, so the interesting thing was we looked at this ID, so lots of devs started twittering this out. You looked at this ID of 673. So the ID of 673 related to TechEd 2012. So the ID was relevant to last year's conference.
That's the
so
session ID, 673.
Correct.
Yeah.
So you have a look here. What actually uniquely identified Kirk as a user? His plain text password. Absolutely. So not only, this is actually quite unique. Sometimes people store plain text passwords in the database, like Yahoo Voices, or go to plaintextdefenders.com and you'll see lots of people doing it. Sometimes they're sent in an email. Here's your new password. That's beautiful. Sometimes you might find them in session cookie or in the cookies that gets sent to your client, like Wheedle. Rarely do we see them as the primary key to look you up in the database. That's actually quite unique. Absolutely. And so therefore lots of people are going through just testing, key equals password, TechEd 2012, and finding all the other people with those passwords.
All the people with fluffy ducks as their password. And
Fluffy duck?
that was yours.
Yeah. I know. That's my one-time password. It's now fluffy duck 2. So, okay. So that was fine. And look, and of course, just one of the bits to always when we show that slide, then Microsoft are very clear that we say that was fixed within hours. And that it wasn't actually Microsoft's doing, neither avenues, it was whoever developed the code for them. Whew, that's my legal get out of jail. That's cool. So, all right.
Let me talk. So what we wanted to show you with all those stories is that hacking affects big companies, it affects US companies, but it also affects small companies in New Zealand. And in fact, it's not always just hacking, it's just dumbass things that we do. Often you'll hear people say, oh, no one's ever going to go after my site. No one's ever going to try and attack me. But the answer is, we're all storing sensitive stuff in our system, so we all have to think about security. So today...
I was going to say, one of the biggest things that we've seen as well is there seems to be a bit of a theme in the industry that people are raising the bar. They're actually getting better. Now they're putting in some CSRF tokens. How many people in the room are familiar with a CSRF token, just to get a feel of, there you go, there's a few out there. CSRF, cross-site request forgery token. So we're starting to find sites that have those. And if you want to come along later on this afternoon, we'll talk a little more about that. But what we are seeing is that, in fact, lots of the basic errors are actually becoming more prevalent. And this is where people are now moving apps to the cloud. Maybe they're adding in more web services at the back end. So there seems to be a growth in a lot of the basic issues coming back.
Sigh. So we're going to do a couple of different hacking type demos. The first set of demos that I'll show are a different type of denial of service. So last year we showed denial of service attacks against Language Perfect.
Yep.
Where it was a network flood type denial of service and then lots of page requests and different features. But there's other kinds of denial of service that will target your specific application and go after the features of your app or your environment. So for example, if you've got a page, say it's a web app, you've got a page on your app that leaks database connections. If an attacker knew this or figured it out, they might only have to request that page 20 times and the connection pool's empty and no other request for any other page will work.
What we've actually seen is quite commonly now, so say if you look at some of the anonymous attacks that are coming through, is they are doing some quite large network layer DDoS attacks, but there are also now more and more quite specific application layer attacks. So obviously an attacker these days will go through and have a look at the weaknesses of your sites, but then what they'll do is they'll throw out attacks relevant to your site whilst they're doing a bigger attack as well, becoming much more common.
So other examples, similar things. So if your app's storing data on disk, then what happens if I upload lots of data to your app? Something CPU intensive, running reports, crunching graphs, that kind of thing. Some features in your application that use lots of RAM. Maybe if I just load that page 4 times, it'll use up all the RAM on the server. Features that use background threads or even regular threads. And then the regular kind of denial of service bandwidth type floods that'll happen. But also they could flood the internal network. So maybe your external network has some defenses against denial of service, but there's nothing to protect your application talking to the database and flooding that connection between those two servers. So the first one I thought I'd show is a regex denial of service.
A regex denial of service.
What did I say?
Oh no, regex, it's all the same.
Reg. So regular expressions, if you're a developer, you would see them all the time. They're a very handy way of validating text. So the regular expression at the top there basically says, match any string where the string starts and ends, so where the complete string matches, and all that's in the middle is digits one or more times. So this input here of 1, 2, 3, the regular expression evaluator will go, well, 1's a digit, move across to the next character, try that. 2's a digit, yep, I can move to the next character and try that. 3's a digit, and I've got to the end and I match. And the way that it does this internally is it uses a NFA, so non-deterministic finite state automata or whatever it is, where it basically builds an engine in memory that can do backtracking and all this sort of fancy stuff. So what happens if it gets invalid input is it'll do the same thing. It'll go through character by character until it gets to the invalid input at the end, and it'll say, well, X was invalid, so let's go back and try again. And it'll pop the last character that it tried, which was 3, off, and it will try and match 3 against a different rule. But in this regular expression, it can only be digits, so there's no different rule that 3 will match. So it'll pop the next character off, which will be 2, and it will try that again, see if there's any different rules. And so the net effect is that your regular expression runs forward till it gets an invalid input, and then it backtracks and tries again. And so it kind of tries every possible path. Hey, your VM looks awesome.
There it is.
Ah, cool.
It was waiting for you.
In the spirit of TechEd, it's awesome to have demos. And I like my demos to have lots of high quality code in them. So here's my demo. So this is an ASP.NET Web Forms page that basically checks if a page is valid or not and displays a text message. This is about my quality of code these days. And you can see I've had it styled up by no one. And on that validation control there's a regular expression. So that's the out-of-the-box regular expression that comes for email addresses. So say I stuck that simple D1 that I was playing with. Sorry about the screen switch there. And then run this. So now my input box should allow digits. So even though it says email, if I put a digit in, it works. It works. If I have an invalid character at the end, it'll match up till the X, and then it'll backtrack and try and match again, and it doesn't work. Okay, so that's cool. What if the regular expression was a little bit more complicated, and the astute of you might have noticed that I pasted the slightly more complicated one into that page? What if my regular expression said match digits and match one or more groups of digits? So with the same input, it matches fine. With an invalid input, it groups together as it goes through the string. When it gets the invalid character, it goes back and tries again and says, oh, 3, yeah, I can group that into a new group. And then it gets an invalid string, so it goes back again. Oh, 2, that can be a new group. Put 3 on the end of that. Okay, try again. Then it'll try 2 and 3, and then it'll try nothing, 1, 2, 3. So you can see that the steps are slightly longer. And what happens is that the longer the input string, the longer the steps are. And it's kind of, hey, look, the dots came at the wrong time. Depending on how long your input is, the square, I think, of that is how long the regular expression actually takes to run. So if I had that regular expression in my code, which I did, so that was /d inside brackets with 2 sets of pluses. Here. Run like the wind. Oh, it's already running. So you saw how fast that was. That was pretty fast. Oops. So if I make it a little bit longer, it's still pretty fast. Maybe make it twice or 3 times as long. Hey, it's going a bit slower now. And so what's actually happening? If I can right-click. How do you right-click on your computer? Oh, that's it. Bloody Mac.
It is, by the way, because it was commented when we brought this up, just to be clear, this is a Surface Windows 8 machine running a full macOS emulator. We just happened to rebrand it just for fun.
Yep, it's got
just to be really
it's a
clear.
sticker on the back. Yeah, so you see that small amount of input with that safe-looking regular expression is now spinning my CPU at 100%, and has been since I clicked the OK button. So now my web server has one core that's busy just trying to validate this email address. So why did that happen? Well, it was that backtracking issue. As the input string got longer, the amount of work to go back and forward along the regular expression, checking different possibilities, squared, or possibly even went to an exponential length. And so to fix this, as anyone that runs farms of web servers know, you reboot.
Beautiful, because you have, in fact, now DOSed our own demo.
Yes, so,
Perfect.
whoops. So you might think that, well, this doesn't really apply to me. No one will ever know what regular expression I use, and I'm not dumb enough to choose stupid regular expressions that have this problem. Well, I went to regexlib.com, which is the library of regular expressions on the internet, and wanted to get a slightly better regular expression for email address because my one didn't handle pluses in it. And so this is only a slightly better one. The even better one is about this long that actually is RFC compliant. And I'll change my regular expression to that. Run again. I can figure out how to use a keyboard. So now, email address of Kirk at. You want to know my real email address? Okay, whatever. We're all friends. It just automatically comes out. So that's an email address. That's not an email address. Still not an email address. Make it a little bit longer. It's doing it again. So just an off-the-shelf regular expression for emails can also spin up one core on your server to 100%. Probably going to have to kill that again. And you'll think, oh, no one will ever be able to guess how to do this with my regular expression. Well, Web Forms has this really cool feature where with your validation controls, you can say, enable client-side script. And so now when I run my page, it'll run the JavaScript in the browser as it validates. So instead of going to the server. So it gives a nice user experience because you very quickly get the error message. But the downside is that when you view source of the page, you know the regular expressions that are running on the server because they're there in the JavaScript. And so if you're an attacker, you could see that what this one's doing wrong is it's got a capture group with repetition inside and outside of the group. And so there it'll trigger that backtracking. So that's one example of a really simple feature that you'd use in your apps that will cause an application-style denial of service. A second example is something simple like parsing XML. So the simplest case that will trigger this, it's not that, that's the more complicated case. The simplest case that will trigger this issue is this code, which I guarantee that every developer in the room has written. Create an XML document and load some content into it. And you might be surprised to know that that's not a safe thing to do on any XML document that gets uploaded to your web server. And in fact, it's probably not a safe thing to do on it's probably not a safe thing to parse any kinds of content that gets uploaded to your web server unless you have like awesome intellect and you can write foolproof parsers, which luckily Microsoft does. And so there's some guidance on how to fix this, which we'll link to on our site. But so we've got this really simple app that just lets you upload XML documents, and I'll show you what happens. So that's this one. Man, the brightness on this laptop's really getting a workout. So this is a website that we've kept evolving since Hack Ed 2009, which is sessions on and different events. So the way we've extended it is now at this event, which we've called TechEd 2013, not the real sessions. You shouldn't go to these sessions. Once you've logged in, which I will now log in with my super secret username and password.
Are you going to use your fluffy duck one?
Yeah, that's actually your username. But anyway, so now when you go to a particular session in this conference, you can leave feedback. How do you upload it?
Well, you've got to be, it's one of the ones that you're presenting, Kirk. What are you presenting? What are we in? What's this session?
Do we have to go to the actual session?
It's the real one.
So he wrote this demo. So there's an upload thing here where you can actually browse to XML files and upload comments in bulk. So say the TechEd organisers wanted to upload comments against a talk. Maybe they could browse to a file and upload it. That one?
Check it.
That one. So here's a few examples of some XML. So right click. Sorry, I find that if I talk out loud, move mouse cursor to the right, move down, click. It's a Scott Hanselman style of making sure everyone knows what you're doing. Cool, so let's make that a bit bigger. So here's an XML file. I don't actually even know if that's valid XML. It's XML-ish. And so what this page does is it uploads the file and displays the content. So that's awesome. So what if the XML file looked a little bit different? So here's one I prepared earlier, PowerPoint style. So this is my XML file that I'm going to use. It's just got a simple &m semicolon. So that's not defined in XML, so you have to define it yourself in your doc type. And so what I've done is I've defined an M as containing 8 L's. And then I've defined an L as containing 8 Ks. So when the parser opens this XML file, the first thing it'll do is go, well, I don't know what an M is, I need to expand it. So it expands it to the 8 L's. And then it goes, well, I still don't know what it is, so I need to expand the L's. And so it expands them to the 8 Ks. And then it goes, well, I don't know what K is, so I need to expand that. So it expands it to 8 J's per K. And so on and so on and so on until you get to A, at which point bad things might happen. And if we're lucky, they will. So I've got the file here. It's called Boom. And this is what it looks like. So just a pretty standard XML file with entities defined in the doc type. And I'm just doing that thing where I'm loading it in an XML document, just taking the uploaded file, creating an XML document, and loading it. Now let's see what happens. So it sent that file to the server. And now the same things happen. The server's spun up to 100% CPU. The cool thing that's also happening is that it's trying to expand all those entities into an XML document in memory. And luckily, this is Andy's computer, so I'm not afraid to leave this running for a while.
Yeah, good on you.
So our web server processor is currently up to
Getting hot.
860 meg, which I think is a pretty reasonable amount of memory to use for a single user on a web server process.
It'll die soon. Hang on, it'll die soon.
Oh.
Nearly.
Do we leave it dying and potentially ruin?
It's going to blow up.
I don't want to ruin the rest of our talk. Yes, we'll ruin it otherwise. So that's another example of where taking input can lead to a denial of service using an application-specific feature in your app.
And so if you actually spun up, say if I had 2 or 3 browsers now, each doing that, it's going to get pretty messy pretty quickly.
So how many people open documents how many people allow uploads into the apps? So if you've got like a SharePoint style thing that allows documents to be uploaded, you allow people to upload images, you allow people to upload viruses, probably all of you already do. It's really hard to test if they're safe. And we've talked about this in the past, and I think, was it last year we made that file upload cheat sheet?
Yep, correct.
So you can go and see on our website, there's a list of things to think about when you're parsing and uploading files, and it's a really hard problem. And as a developer, I find that the easiest way to deal with hard problems is just to say no. So I suggest that you do that too. Always focus on the easy problems. So while we're here talking about XML, I'll show you another XML attack, because this one's kind of fun. Where'd my web browser go? Okay, it's gone. Damn it. So there's other kinds of attacks that you could also do against using XML. And one of them is called XXE.
XXE.
Which stands for External XML Entities.
Correct.
XML External Entities, something like that.
External entity external. One of the two.
Yeah. And so like the entity expansion attack, that billion laughs one that I showed, this one is quite similar. So can't remember that stuff for you. So I'll show you the file. So it's a very simple XML file. Basically, I've defined my own entity type, and at runtime, the server is going to try and figure out what that entity is.
Correct.
So let's load it and see what happens. Cool. So the really cool thing about that is when the XML document opened, the default behavior of it is to expand all these entities, even if they refer to other files on your server. And so those of you who have a history of using Windows might recognize the contents of win.ini, which for some reason still sits on the server. It's a nice short one to type. And so now I can just browse around your server by changing this path here.
Absolutely. Could be local web.configs, could be, well, anything that, again, is accessible by the web server at this point.
So let's try a web config and see if we can see that. I mean, the good thing is no one stores database passwords in their web config, so that should be fine. Okay. Well, this website's even better because it's also telling us the full path of this XML parser as it's running, which means it's going to make it a lot easier to navigate around directories. So you can see how it's really easy to do something simple like parse XML and muck it up in a complicated way.
And so what's kind of crazy, we've actually seen a lot of this in the wild these days, and we've seen a number of them where it was particularly the web services that are being setting up for the mobile apps. So the main web interactions are all fine, but this is where we're putting in very strange requests coming in from the mobile app for the mobile web services because they are just used to now consuming XML and you seem to have turned off all thoughts of parsing and validation when something's coming from a mobile device. It seems as though well, we can't trust the browser, we've learned that one, but we are trusting the mobile devices and what they're sending through. But they are just as compromisable. So I guess, so for the, oh good, so my last little 20-minute window.
It's not the last one.
Hey?
It's not the last one. The next one.
The next one.
Cool.
So
don't try and steal
what we've
my
seen,
slot.
again, quite a lot of on a number of sites is sites that are flipping between HTTPS and HTTP. And whilst they're doing it, they are spewing out far more information over HTTP than they really should be. So, as an example, so sitting in the on the wireless last night on the Sky City Wireless, so I had Kirk and I browsing around the Hack Ed website, and so this little stream of information here. So the tool that I'm just firing up is a tool called Wireshark. I'm sure that lots of you have used Wireshark in the past. One of its best uses, or if you're on a shared wireless network, I say best usage or worst usage, is it's incredibly good at just trapping all the wireless traffic that's going past you. So the little list we have here, it was actually capturing all the traffic that came from Kirk's browser, from my phone, capturing all the traffic that was going to our test Hack Ed. Now most of it was over HTTPS. So key thing I'll show you is just see all these HTTPS requests. If you actually want to go and have a look at HTTP requests, it's pretty nasty on the inside. It all just contains completely encrypted information, as one would hope. Unless, of course, if the NSA have broken the crypto as part of the stuff that Ed Snowden's talking about. But that's fine. Let's assume the HTTPS is valid. Now, you'll see there's one little couple of green lines down here. Oh, no, I don't want to get arrested. So a couple of green lines down here. So what was this? So there was one request. And I'll show you the demo in a minute. One request. The whole site's over HTTPS. One request popped to one page over HTTP and came straight back. That's all it did. I didn't post any data. It was a GET request. So this little green thing. So Wireshark says, oh, sweet, I could see that. So one little, and so you can see it was just a GET to the root. And then it also had a look for the favorite icon and then had a look for a little Apple PNG. So let's have a quick look at the TCP stream that followed. So you don't need to see that in detail. All I'll show you, and then I'll run through it in a minute, is this little chunk of stuff that actually got sent through in that single GET request. Because we're not using the right HTTP headers here, and we'll describe some of those later on the server and what you should be using. But the two chunks of information that are quite nasty that got sent is the ASP.NET session token, and the ASPX auth token. And so, boop, there we go, highlight that baby.
That made it worse.
It did, didn't it? So what are we doing? So all we've done, so we've logged into the site, and all that's happened is that those two little chunks of information have gone through. And so this is basically session hijacking 101, that we've got the auth information and the session information that we need. It was all secured over HTTPS, and one request came out over our Wi-Fi that happened to display the information. So what does that mean to our site? So what I've got here, I've just got the site up and running. So many of you will be familiar with the idea of, say, local proxies. There's a number of them. We tend to use Burp most. Burp is just a great testing tool. You can have a look at the HTTP traffic going through, useful for security testing. So what have I got? I've got my site here over HTTPS. So I will log in over HTTPS. And behind the scenes, our burp down here is actually running and seeing all these HTTPS requests coming through. That's fine. And as we saw in our little window, all the HTTPS stuff is hardcore. Can't get to that. So here we go, Andy Prowl logging in. Fluffy. How many of these? That's a good strong password. Look at that. Okay, so what have we got? So we've logged in here as Andy Prowl. So it's all over HTTPS. So our attacker at the moment hasn't seen our username, they haven't seen our password, can't get into our site at all. Then we happen to have one page, one resource, one get that takes us back to the HTTPS or HTTP version of the site, one request, and then we jump back to our HTTPS version.
So it could be as simple as one hyperlink, one image,
Check.
tag,
CSS,
anything
Absolutely
on
so.
your site that
One
works over
request.
HTTP.
And so what happened? So I was running my Wireshark. I happened to do this over a shared wireless network. And so we jumped down here. All of this is HTTPS. I did my one get. So the ones that I highlighted a second ago, you saw it in the Wireshark window, 2 chunks of data, session ID and my ASPX auth token. So what else have I got here? I've got another window that's open. I've got a private browser window. So this here is not using the same session information at all. And if I have a look, I'm not logged in as anyone. Okay? All I need to do, I'll jump back to my burp window, and what I'll say is, I'll tell you what, intercept the request that just comes through, and we'll just refresh this page again. So what I've done, I've now intercepted, so this is the GET request that's coming through. So this is my normal session that exists in my new in-private browsing window. It's not logged as anyone. However, all we have to do at this point is now insert the stolen session ID and the ASPX auth token that we stole from that one request on the previous site, forward that through.
Turn off intercept.
Boom. Thank you. And straight away, our in-private browsing window is now logged in as Andy Prowl. So just a simple session hijacking through the one request over HTTPS. So for anyone who's doing sites that are actually making one request, you say, I'll look for performance. My login's over HTTPS, so you don't see the username or password. Everything else is over HTTP, broken. Because your auth tokens will be traveling over HTTP unless if there's a number of settings that you can put to ban this.
Yeah, and gone are the days that you can trust the network that you're using or the network that your users are using. I mean, people are connecting to all sorts of crazy Wi-Fi networks just to save money. I mean, you guys probably all connected to the TechEd network today. Was that actually encrypted? Actually, it might have been because there was a password. But maybe you've stayed in a hotel or you've been to Starbucks or McDonald's where it's an unencrypted, open network. Anyone can connect to it.
Yep, anything like that. If you're in Koru, any of those, anything that is over a non-secured wireless network that you then use a web page to actually do the auth.
You know that some of us that aren't managers don't get to go to Koru?
Oh, really?
Yeah.
Yeah, well.
Do you have to bring it up every time we meet?
Oh, sorry, dude. Oh, bit of Koru jealousy going on there.
Jetstar don't have a club.
Yeah, it's my boss is cheap ass and sends me on Jetstar Club. Dude.
Yeah. It's the 2-hour wait, then the 2-hour delay, and then the stay overnight club. Yeah.
So the second one. So we mentioned before. So the new advanced threat that we're seeing more and more and more and more of. We mentioned at the beginning. So I'm sure that many of you hadn't have heard of this SQL injection. New thing that's coming through. It's pretty newfangled and it's kind of scary. It was found in the early 80s before we had websites. It seemed to be resolved in the early 90s, so no one had SQL injection anymore. And here we are in 2013, and poof, SQL injection all over the place. So we actually had a client who, we had just one client.
Okay,
All
business is
right.
going
We
well
have two
for
now.
you.
I know, we've doubled up.
Awesome.
So the client in question, they had a lovely secured SQL Server connection going on. It was stored inside their own environment. It was going to the AD between the website and the SQL Server itself using integrated identity. So there was no issues. The web config was fine. There was no dodgy passwords happening. And then they moved this not into the Azure cloud. They moved it into the AWS. And so what did they do in AWS? They took a backup of the database. They created a standard AWS instance, and boff, they chucked it in. The standard AWS 2008 SQL Server that they used had the good old classic. So guess the user account that it used in the connection string. SA. Boof. So, and the reason we knew this is because they actually got owned and attacked through an XP command shell attack, even though it was completely turned off. And they went, it's impossible. And the DBA said, no, we don't run XP command shell, yet we can see in the logs we've actually had some valid XP command shell working. And so this is what happened for these poor fellas.
Yeah, so before we get into this, I'll show why this is, I'll just talk about why this is still an issue. So when we built our first Hack Ed demo in 2009, umming and ahhing about whether we should talk about SQL injection, because everyone was using newfangled stuff like Entity Framework and Link to SQL to write their database logic in C#, because they were using these ORMs like Lightspeed, rather than writing handcrafted SQL. And so SQL injection, I think, was kind of on the decline, or maybe I was just being hopeful. But people still had to go on hand-rolled store procedures every now and then in order to do complicated stuff like searching and sorting, maybe a bit more dynamic types of queries. Yep. And so at that time, the types of SQL injection we were seeing were normally when developers left their comfortable ORM world and went to something they were a little bit less familiar with. Since then, what's kind of happened is that people have got a little bit less excited about ORMs, and it's possibly something to do with Entity Framework. And so people have been looking for faster alternatives. And there's an ORM replacement kind of thing that came out of the Stack Overflow guys called Dapper. And I think it's kind of the new cool in terms of accessing your database. So pretty much what you do in Dapper is that bottom chunk of code where you say, run this query against the database and return me a set of objects that conform to this shape. So the standard kind of thing you do against an ORM, which is, give me all the people, it gives you people objects. Except with Dapper, you just write the SQL yourself in your code, run it against the database, and it returns you the objects. So the good thing about Dapper, the reason people love it, is you get to have complete control over your SQL. You can hand tune it and write it as tight as you can so that it runs as fast as you can. And the other benefit of Dapper is, as opposed to using stored procs, your SQL code is versioned in the same place as your C# code. So when you deploy this site, when you deploy this method on the site, the SQL code that it needs and the C# code that it needs go together. You don't have to worry about database deploys. So that's kind of a little history of Dapper. So, of course, with every new technology, people mess it up. Could save myself there. Hey, that's pretty cool. I like what your computer's doing there.
Did you like that?
Yeah.
Yeah, it's quite pretty.
That's good.
Yeah. That's happens with the OS X emulator.
OS X, and we're running parallels inside it.
Good.
Yeah. So inside our website, we let people search for sessions, and then the way that they do this is they can type in a query. So where's your browser? Oh, it's in there. So to search for a session, you go to the session search dialog. You can use the regular stored proc search, or you can use the fandangly Dapper search. You can type in a term that you want to search for. So I'm going to search for SQL because it seems kind of fitting. And you can see all the talks that mention SQL in the title. Hey, that would have been way better if it had worked.
So your SQL injection works, but your standard... So there you go.
Yeah, okay,
That's
so
fine.
maybe we didn't have the word SQL in any talks. We don't.
No.
Okay.
Try Azure. Do I?
Okay, yeah, everything's about Azure these days.
I know.
Man, move your SQL injection to the cloud, and it's as simple as 2 clicks.
Now, you can get SQL injected really quickly.
And so here's a picture of and I've seen code like this, so I've reviewed apps that use Dapper, and I've looked at samples on the web. And what happens is programmers do what programmers do. So they go, hey, I need to write this string in code, and I need to put a search term in the middle of it. Well, I know how to put things in the middle of strings. And they fall back to the old pattern of string dot formatting their SQL statements. So now if anything dangerous turns up in the search term, it's going to end up in the middle of the SQL statement.
Check.
And they'll do things like, I want to add an order by clause that's different, and so they'll make a new function, called like order by, and they'll assign that to the end of the query, their order by clause.
That's our secret 5-minute piece of paper.
Oh, we've got 5 minutes left. It's not a secret anymore.
No.
Cool. So I better switch over to Andy. But what you'll find if people are using Dapper, I'm not saying that Dapper is bad, but it's just that programmers turn it into C# code. And so instead of a single SQL statement like you have in a stored proc, you end up with an object-oriented, dependency-injected way of generating SQL out of strings. So why is this a bad thing?
Why is this a bad thing? So I guess so just for the little Hack Ed demo first. So look, apologise to any of those who've been to one of our training courses and played with this stuff. But the reason I like this little demo is so this sysadmin was quite shocked because they had no XP command shell there in their Win 2008 instance, and yet got munted. And so one of the bits that some people know about and some don't. So I'm always a fan of see it in action first. So look, if we try, as an example, we've got all these pre-built
Do you first off want to show how you even know there's an issue? With the single
No,
quote?
absolutely not.
No? Okay.
So I guess hopefully people are aware these days that if my name was O'Brien or I was searching for O'Reilly, whenever we see websites that break with because we put a quote in, that's a SQL injection, and people are aware these days. So when we see quotes with double dashes, not going to go into SQL injection 101, but so we can see that there's some SQL injection, and there's a lot of sites we find that are vulnerable to blind SQL injection. That's when the errors don't appear on the screen, and yet you can still break into them anyway using timeouts. But the key thing I just want to show here is, say for instance, we actually go to run an XP command shell. So what's going to happen? So this is actually going to break, and it's going to go, nah, forget it, dude. You're not allowed to run XP command shell because it hasn't been configured on this server. However, the database in question up on AWS running as SA, it's kind of game over anyway, because if you're SA on the database, for those who haven't seen these very handy commands, then the first one that we run via our search page is we reconfigure the server to show advanced options, because it's only through advanced options that we get access to look at things like the XP command shell. And so that just runs. It doesn't return us any results, but of course after we've run that, we do need to go and just reconfigure our database at the back end via our search screen, which is always a useful thing to be able to do. Cool. So now what's happened? So we've so by showing advanced options, we now have this option. So who out there in crazy hacker land thinks they might have an idea what spconfigure XP command shell 1 might do? Come on. All those wannabe hackers. Turns it on. Admittedly, there was a slight bit of information disclosure in that little statement there. However, and it wasn't just because Kirk finds this really exciting. Well, I'm not going to say any more than that.
I'm not going to comment either.
No, dude. When we're going through some of those late night practices, it's like, dude, no, really. This is not tech porn. So what have we done? So we've turned this on. So what does it now mean? It now means that if I go to run my XP command shell, the one that was disabled by default because it's a security flaw to leave it turned on, but even though it's a security flaw to leave it turned on, why is it not a security flaw to let me turn it on?
It's because you're SA, you can do anything.
Exactly.
You're
so
God in the
what I do,
database
so I can
world.
run some command shells, and I guess very similar to the to what Kirk was doing a minute ago. So what would we normally do if we're running something like this is, as you would have seen, so I can now run any arbitrary commands at the back end. And so, as an example, we might just have a quick look-see and have a look at who are the netusers.txt. Who are the users? Oh, it doesn't exist. Okay, so how about we just go and find out who, for instance, are the users on this machine. Here's one I prepared earlier. So we run a back-end command shell to actually run our netusers command. Boop. Dump out the results of this file, which hopefully will now exist. Oh, look, we have administrator guests and training. So again, so what we're now doing is we can run arbitrarily any commands on the back end, and we're now running not as SA. If I was to do a who am I, it would actually, in this instance here, return system. So we're now running system. There's no UAC popping up to go, oh, actually, should you be doing that? Nah, this is game on, raw, system commands coming through. And so this was one of the ones that we actually really saw in the wild on AWS. So I guess that is us.
You know what, Andy?
Yeah, baby.
We never really had a chance to chat today.
Chat like what? Not one of those chats. Yes, Kirk.
Snapchat.
Snapchat.
Yeah. So what do you think of this audience?
Oh, they are awesome, mate. Awesome. Thank you. Thank you. Thank you.
Thanks for coming.
Thank you.
See you back here at 20 past 3.
10 past 3, 10 past 3. If you see us back here at 20 past 3, then you're late and so are we.
Don't bring up that slide, that's embarrassing.
Oh, is it? Oh, okay.
If you want to see
Required-
more information, go to hacked.com with a minus in between hack and ed.
Yep, absolutely. Thank you
Thank
very
you.
much.